All right, let's talk about optionals. Um, yeah, so when you look at typical programming, sometimes you have or what, not sometimes, but most of the times you have like variables where you don't notice, like actually if there is a value stored in that variable or not. And because doing runtime, it could be that like a user enters like some values and you have to store them in that variable or whatever. But you have methods somewhere which call that variable or can call that at any time, for example. So how do you make sure that your code doesn't crash during runtime because your program tries to access a nil value, which is called in Swift, or a null in Java? And then for that we have optionals, right? And in Swift, as it is a super type safe language, you can use optionals as an additional tool just to make sure that your code actually has a nice flow, works, and so on. And optionals are great for that because you don't have to do big nil checks all the time, um, because a compiler will remind you that you have to do something with that option before using it. So let's just see how that could work. Let's define a method, and we just call that um, baking state because this is a baking machine. You know, those you see in those grocery stores. And theoretically, the user can input um, a baking good name, for example, and we will return a string. And then in here, we just say we build a switch over baking good, and in our first muffin, right? In our first case, we have a muffin, and here we would return, I don't know, muffin got into the oven, baking time, I don't know, 30 minutes. And our second case, let's just do two cases, could be a banana bread. And here we do pretty much the same thing where we say banana bread and into the oven, baking time, I have no clue, like 75 minutes. And our default will just return um, something like not in database. I don't know. So this is our function. And if we call that function now, we can say check baking state, and then we can paste in, for example, the muffin. And we actually should then see the right string coming out. So while this is compiling, I just keep going. But what would happen if I pass in a string which is not handled by the switch case? Of course, it will go into the default case, right? So let's try that. Let's try an apple pie. And then we should actually see not in the database, right? Not in database. Okay, so this is not really helpful, right? If now if imagine you're the API caller, you want to call check baking state, and your user puts some like apple pie into the user interface, and if the API caller passes it into this method, and then he will get not in database. Great. So what to do now? Okay, of course he could or she could take the string and just pass it through into an alert dialog, but that's still not really helping the user. So how about this method up there can return a string or can return no string at all. So if you would call the method and pass in the baking good name, and it would land in the default case, it would return nil, and the compiler will force the API caller to handle that nil value. So he or she knows, okay, in any case, it could be that there's a nil coming back, so I have to handle it and do something meaningful with it, right? And that's again, it's not like the best case where you want to use it, but that's like something you can do. 50 minutes in average baking time. Hey, I wasn't too bad with 75. Um, yeah, so let's just change the method to return a string or nothing. So let's just call a baking state new, and then we have the same signature here, argument here of baking good string, and here we return a string optional. So all optionals are declared with a question mark, right? That tells the compiler that here our return type is actually a string optional here. So what we can do now is we can just copy that code here, and here we return just nil in that case. And if we run that, you see the compiler is not complaining because we declared it as optional here. So what happens now if we call that method and pass in apple pie again and just quickly compile that? Oh, we gotta call the right method, right? There you go. And then we call that. We should see what happens. There you go. We'll get back this nil here, right? So this is how you could use optionals for example, but then you can, and we get into that a little bit later, but then you can do conditional, like some sort of a conditional check on that optional which gets returned here, and and then you can use them later on if you check on them, but I go into detail a little bit later. So this variable stores nil now, right? And it's totally valid. It's fine. We can do that. It would be different if we would assign that return type to something which cannot be nil. Then the compiler would actually complain. So let's just talk about storing optionals. Like this was just a quick introduction, just quick idea of what optionals are. But if we check on the baking state, we can say our baking state is a string, and that's an optional because we might not know the baking state. And then we can say baking state is check baking state of muffin, and then we can print baking state here, and we can see it says optional muffin got into the oven, blah blah blah. So optional string. So we get the debug description here. So what it says, expression implicitly coerced from string to any. So in that case, what we want to do is we want to actually, before we do anything with that, we want to safely unwrap the optional. So safely unwrapping an optional is pretty much like a null check in Java where you say like if object equals null, then do something. So this is kind of the same. So there are two ways of safely unwrapping an optional. One would be using the if flat, see you Maxi, if flat, and then we can say baking state equal our optional baking state, right? Like our optional baking state here. And now what that allows us to do is it says, okay, we have baking state, this one here, which is an optional, and we tell here to say, please look into here and see if there is nil or actually a value in it, and store that, if there's a value in it, store that in this baking state constant here, and then I can use it inside of my closure. So I can actually start printing out this baking state now, and I don't get a warning here anymore. So we see it just printed out properly in a proper way as the string is supposed to be. So the next, like the other one, would be a guard statement. And a guard statement is a different way of safely unwrapping an optional. It's just a different type, which allows you to have a different flow. So let's say we have the baking state again. And here you can see instead of an if, we say guard let baking state equals baking state, and then we say else. So that means pretty much, please check if in baking state there's a variable or not. And if there's actually a value in that variable, all right, then we can use it outside here, right? So the baking state is visible and accessible outside of here then. So we can say print baking state. Let's just make this, just do that. So we can print baking state outside of here. But what you can see is it says guard body must not fall through. Consider using a return or throw to exit the scope. And that's super important to kind of understand when you want to use which, right? There's not I don't have a fixed rule. Maybe someone has, but I don't have a fixed rule. I just look at the code flow and which feels good and how I need it. But an example would be if you load data from a backend and you get back, for example, a result set, and that result set there's a value or an optional error in there. Actually, both of them probably are options. Then you want to safely unwrap that error first and say and use a guard in that case, because we're saying, okay, if there's an error in my result set, then I want to just return out of this method anyway, right? I don't want to continue executing all the code which is below. We're done here. There's an error. So that's when I would use a guard. And if let, a little bit different. It's more like, imagine you have a UI element, and you only want to fill that text field, for example, if that value is actually there. So you could, for example, use an if let and then just pass that in. There are different ways of actually handling like strings. You put strings and default values and things like that, but we're talking about that a little bit later. But this is how you would use a guard statement. And then here you could handle your errors. Oops. And then, of course, as it says, you got to return out or throw an exception. So this is happy now. And then if we would call check, it should do the right thing. Yeah, you see, it's printing out that one. Let's just try doing, let's just actually force an error to happen. Let's say this is not muffin. This is the apple pie again. And then let's just run this. And yeah, we see not in database, because that's actually the baking state, because we're calling this one here, right? So we're calling this method, which in the default returns not in database. Then it goes in here and it tries to safely unwrap it, but because there's actually a string in there, it prints out that one here. So what we actually want to do is, yeah, we actually want to just say, we just comment that out. So yeah, we see error happened. See, because this is of course nil. We never assigned any value to it. So we run into that guard block, and then it prints out the error. So those are the two ways you can safely unwrap optionals. And yeah, let's just talk a little bit more in detail about optionals here. Let me think what I can show you here real quick. Yeah, so as I said, the guard statement helps you to fall through here in the method, and it's helpful, can be helpful. Let's see how we can safely unwrap multiple optionals, right? Sometimes you might have like multiple optionals, and you want to safely unwrap them in like one line of code without writing a lot of clutter code. So we just create a new variable, time remaining minutes, which is an int optional, and we set that int optional actually. Time, oops, there you go. Time remaining minutes is 30. And now what we have here is we have the baking state, which is a string optional, and we have the time remaining minutes, which is an int optional. And now we want to use the if let to safely unwrap both and do something with it, right? So, and that works the same way with the guard, right? So we can say if let baking state 2 equals our baking state. So we safely unwrap baking state optional. And then we say let time equals our time remaining in minutes. And that's it. So you just separate them by comma. And that's all you got to do here. And then in here, you can now say we want to print our baking state 2 and our time. And that's how you would safely unwrap multiple optionals here, right? So you saw the question mark, right? When we declare a variable or an optional in general, like var my optional is type int, or actually it's just a name, string optional. And now it can happen that at some point in code you want to use my optional variable, right? But you know for sure, 100% sure that there is a value in my optional stored, because the flow of your code makes sure that this happens at this point where you want to use it, right? Let's say I'm just making here a comment. You have like all your code here, right? And then you got some method at some point which is supposed to greet the user and gets a name in, right? A string. And it would print that out to the console, or it's actually going to print that out to the console. So here, what we would do is we would say print name, right? So we print out directly the name we pass in, and that's how we would actually get that name. So let's say we call that hello, and then we pass in Kevin, and then of course what we expect would be it prints out Kevin. So what would happen if we pass in my optional here, and we know that, right? We did that before. It says value of optional type string must unwrap to a value of type string, right? So string optional must be unwrapped to a value of type string non-optional, because this method expects us to have a non-optional here. So what we could of course do, if we could do our if let unwrapped optional is like my equals my optional. But what you also could do is in a flow where we're sure my optional here is set because the user put in his name at some point or whatever. I don't know. But we know if it is set at this point. So what we actually could do is we could say hello, and then we take my optional here, right? And put in an exclamation mark. And that means for the compiler, thank you, compiler. I know this is an optional. I know there can be a nil in there, but I'm 100% sure that at this point, I can unwrap that without having the risk that my code crashes, and that's called force unwrapping, right? This exclamation mark you see here is called force unwrap, and if we run that now, we will actually get an error, right? Because we have declared my optional here, and it says execution was interrupted, reason execution bad instruction, and that's because we try to force unwrap that optional here, unexpectedly found nil while unwrapping an optional value, right? So using force unwrap is great if you have the reason to actually use it, right? To be honest, think about it twice before using a force unwrap, because you can see your application will stop running as soon as we run into that line of code and you force unwrap an optional and it's actually not there. And that's really not what you want when you're writing an app, that your app crashes just because you haven't handled options the correct way. So what we want to do is, of course, we want to make sure that my optional is set to a name or to a string actually, so it's filled, and then we can see it's printing out John as it's supposed to be, right? So this is how you could force unwrap, or how you can use a force unwrap in your Swift code. All right. So let's see how implicitly unwrapped optionals work. So as we declared, optionals might or might not have a value. So it's kind of like the Schrodinger's cat kind of deal. And you have to unwrap that optional somehow, safely or force, before you can use it. And you can also use those optionals, as we've seen before with my optional, to actually declare them in the variable declaration, right? But with implicitly outright optionals, we're talking about variables which might have a value or not, but also with the difference to a regular optional is that the Swift compiler doesn't really notify you when you're using them. So you're using those variables on your own risk. So that means if I take a variable, and this is my, I don't know, my var, my implicit optional, and this is of type string, and now we just put an exclamation mark here, right? And that declares it as it declares it as an implicitly unwrapped optional here. So of course, if we would call hello now, and we can pass in my implicit optional here because it's unwrapped, right? That's if you want to see it that way. So we can just pass it in here. But if we execute, we get an error here, right? Because we haven't set a value here. So really be careful when using implicitly unwrapped optionals. I like to use them, to be honest, in iOS when I have navigations. For example, I have screen A, and I navigate to screen B, and screen B expects data input from screen A. And I know at the point of the prepare for segue, so at the right before we do the transition to the new screen, I want to set this value screen B expects from screen A on screen B, and the variable declaration in screen B could very well be an implicit unwrap optional here, right? Because at this point, when the new view controller gets loaded, right, we are 100% sure that that value is there and we passed it in and it's all good. So we can do that. And it just helps you structure your code in an easier way because it allows you to not have iflets or guard statements for variables where you really don't need them. But again, really think about before using those, right? If that's the right way to do it. So let's move on to optional chaining. So optional chaining is if you call a method or access an attribute on an optional data value, and this is like through the dot notation, and this can be super helpful if you want to only call a method or access an attribute if the data value is not nil. Instead of making a guard statement, you can do that with optional chaining, for example. So what I mean with that is, and for that, I've got to just write some code. Let's have a simple method. We call it method 1, and it returns an optional string. And in here, we have some random number, right? And we just generate that through the int random in 1 to 10. So we get a random number between 1 and 10. And then we create another switch statement here where we use the ranges we learned last time, 1 to 5. And then we have, or actually that's stupid, random, and then case 1 to 5. And then we have a case where we have 6 to 10. All right, and the default would return nil, and this would return some arbitrary string, and this as well. Let's do, or actually just return nil as well, just for the kicks of it. All right, so nothing new here for you, right? It's just like a method declaration with a return type, and it does something. So what I mean with optional chaining is now, if you want to print out whatever this method returns us, right? So method 1, of course, we know the return is going to be string optional, so we do a question mark. And now what we want to do is whatever this method returns, right? We want that string to be uppercase, right? So here, and let's just like do a quick string here. And we want to print that string out uppercase. So we can actually call, like we're calling the method here, we're getting back a string optional. On that string optional now, we can use optional chaining with the dot notation to call a different method on string, which is uppercase. So what that line of code means now is, let's just break that up a little bit. Let's just see that here. So what that line really means is we're calling method 1. We will get back a string optional. So at this point, we're not sure if there is a value stored or not, but we want to call uppercase on it, and we don't want to do a check on it because we're lazy. We can just do optional chaining, and this uppercase only gets executed if whatever method 1 returns is not nil. That's basically what it does, right? So what we're seeing is optional whoop whoop. It's all good. It's uppercased, so it applied the method on it. And let's just change that back to nil and just run it again and hope that it's actually going into the nil case. Oh, you know what? Let's just change it to 5. And we see we get nil back here. It's not executing the uppercase on it because there is nothing to uppercase. So that's how you could use optional chaining in that very example here. Optional chaining can be super helpful in in different ways, right? It's not only like in that case here, you can use it in all sorts of things. Like let's say you have I mean, we can talk about that the next time. But let's say you have a class, and in that class you have a variable which is an optional, and you instantiate that class, and you want to access that variable which is optional, and then on that you want to do something else. You would use optional chaining again. Um, if you only want to execute that method call if the value is nil and not do anything else. If you want to do something else and you really want to handle the different cases, you want to use an if let or a guard statement. Yeah. So yeah, theoretically you can chain multiple calls here. The last bit on the optionals, and then I probably let you go a little bit earlier today to try that out, so you can try that stuff out, because there was quite a lot, I think. But we have the nil coalescing operator. So let's say you have a city variable. I mean, like a variable city, and you want to print out the city in which a customer lives in. But now the city can be filled or not, so you don't know if the city is actually filled by the user. So what we want to say is actually, if the city is filled, print it. If not, print something else, right? And I've briefly, not really talked about it, but I've mentioned it. This is like a different way how we could treat optionals by providing a coalescing operator and providing a default value. So let's say we have a city, which is string optional, and then we want to print out that city, right? And that would return nil now. And even if we would fill that value, it would tell us that we actually got it, or we'll print out the debug description with the optional. It's all not what we want. But we also don't want to use an if let. We don't want to use a guard statement. Optional chaining we cannot really use. So we're using the coalescent operator here. So it's a question mark, so city, question mark, and then your default value, no city, right? So what happens now is if we run that, the compiler knows, okay, if city is nil, we actually want to print out no city instead. And that's a pretty cool way. See here, no city over here as well. So that's a pretty cool way how you could handle default values, right? The same thing for default values in methods. Let's see if I can get it together here. But let's say func my method, and then we get in some string, which is a string optional. And then you could theoretically declare a default value here if you wanted to. And that's what you can do with all sorts of like with variables, constants, not actually constants because they gotta have a value, but variables, you can have default values for optionals in method declarations and things like that. But that's a pretty cool thing, and you can do that with all sorts of data types. You can use integer, so we can say print my int, and then we can say, oops. I mean, this is totally valid as well. Yeah, it's all right. Just ignore this stuff. So yeah, those are optionals. Let's just quickly recap before I let you go try it out. So optionals are variables which can have a value or not. And you can declare an optional with a question mark. So the compiler knows you want to have it optional. You can have optionals in all sorts of data types and objects, or you can have all sorts of data types and objects as an optional. If you would print an optional, for example, you get a debug description with the optional thing, with the optional keyword around it. You can safely unwrap optionals with the if let or with the guard let statement, depending on the flow of your code and what you want to achieve. You're using if let, for example, if you directly want to react or interact and manipulate or do something with that value here inside and then continue with the rest of your code. A guard you could use, for example, for error handling if you say, okay, the rest of the code doesn't have to be executed inside of my method if there is an error, so you can let your method fall through here. You can do safely unwrap multiple optionals here by separating them with a comma. That works for if let and guard. What did we discuss here? I think we did discuss, let me just look at my notes. Optional chaining. So we got optional chaining covered here, how you can use that. And also the coalescing operator down here, which gives like an alternative value back in case our variable is nil. And with that, I'm open for questions if you have questions. If not, I hope you had fun and learned a little bit something today about optionals. And we're going to talk about enumerations, structs, and classes in the next Get Swifty live stream. So I'm sticking around for a little bit, just waiting for questions if there are any questions. If not, I wish you a great rest of the week. All right. We're done. If there are no other questions, if you have questions, just put them in the comments below in the recorded video on YouTube on my channel, and I will answer them there. And I see you next time on, I think, Friday, talking about enumerations, classes, and structs. And keep you posted. Thank you for watching, and see you next time.